welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with Pavel, who's DevRel lead at ZKM, and our guest, Teemu, founder and CEO of Gevulot. So thank you so much, Teemu, for being here today. We're very excited to have you.
Thank you. It's nice to be here. Excited to chat.
Yeah, also very excited to chat. I'm wondering, Teemu, if you can first start off with a brief introduction of yourself. So maybe some details on your story on how you got into the Web3 and ZK spaces.
Sure. Yeah, there's probably like I'm not sure what would be the right length version of this, but I guess the story of how I ended up in Web3, although it wasn't called Web3 back then, was that a friend of mine and we got very excited about Bitcoin back in like 2011. He had discovered it on some mysterious forum somewhere. And I had been kind of heading towards a career in traditional finance. Initially I was very excited about programming when I was young, but then my parents told me it's complete bullshit and I shouldn't do that. So, so I was headed towards a career in finance later, sort of have moved back more and more into the technical side of things. But having kind of seen a little bit of what the finance or the financial industry was like from the inside by that point, so this is sort of in university, I'd come to the conclusion that it's fairly broken, or at least the incentives are a little bit messed up. And I saw kind of an opportunity in Bitcoin to try out something new and change things. I was quite convinced that changing the traditional financial system was next to impossible. And so we needed somehow like a blank slate or a sandbox, however you want to think about it, where we could experiment with new models and structures. And then just in general, the idea of having kind of a native internet money was, I think, very exciting. So yeah, we got really into it. We, got some Bitcoin, day traded Bitcoin for a little while back in like, it must have been 2011, 2012. Made some money, lost some money. The usual day trading experience. Decided that I'm probably not a day trader. And during that time, we just found that it was actually pretty hard to buy Bitcoin in Europe and most countries at that point. There were not a lot of exchanges. And this is back when MTGOX was like the main thing, right? And so we started seeing Coinbase come up in the US, and we were like, that's a good idea. And so we did that, but for Europe. And so 2012, we launched a Bitcoin exchange called Coinmotion, or actually under the hood, it was what was at least back then known as like a hybrid exchange, where we would use Bitstamp or Bitfinex for liquidity if we didn't have enough internal volume to sort of execute the trades internally. And we tried to make it kind of a very user-friendly experience like Coinbase was. And we were also, I think, probably the first in Europe to implement like full KYC for all users from day one, which turned out to be kind of a bad idea because there was a lot of volume going to places without KYC for whatever reason. And so it was a bit harder to actually grow. But we did that for a little while. Coinmotion is now still the biggest kind of it's mainly like a brokerage type service now in the Nordics. But back then we eventually just got pretty fed up with it, mainly because running an exchange is sort of like 95% customer service. We would get all kinds of crazy messages. People would be like, I sent some Bitcoin from your service to this place. And we would check the address, and it was a Silk Road address, and it's like, and it had gone, and he was like, can you help me get it back? And I was like, well, no, that's not how it works. And so, yeah, so a lot of that kind of the operational side of that business was like interacting with law enforcement, customer service, that kind of thing, versus technological at all. And of course, back then there wasn't that much technological going on. When it was just Bitcoin, it was pretty limited in like the kinds of things that you could do. Like you could be an exchange, you could maybe be like a Bitcoin lending provider or something like that, but that's about it. Unless you were going into dark market stuff like mixers and marketplaces. So we ended up selling it to a competitor, and that's kind of where it all started. And then after that, I did an unrelated, or sort of like stumbled into a video company, which did these highlight videos from Twitch streams back before there were any videos from Twitch streams, and that grew very quickly, but was ultimately unable to monetize the content. So that was an interesting experiment, delivering video to like 175 countries across the globe. Not fun trying to figure that stuff out. I wouldn't recommend doing a video startup to very many people. And then the lead investor in that company was USV, and USV was very prominent in sort of the crypto investment circles. And so then I spent a bunch of time kind of like helping them and things, and just in general, staying in the crypto scene, as it were, as kind of like a side thing. And that's sort of, and then I kind of just did that side thing. Like once that startup eventually like ran out of money because it wasn't able to monetize. And then I kind of started, or just did that side thing as a full-time thing for quite a while. So I worked with a bunch of different companies, some of which are well known now and some of which are gone. But I think like the well-known ones, I was the first advisor to Dapper Labs before they launched CryptoKitties. Back then I was staying mostly in New York, and so I went to visit them in Vancouver, and they told me about this. And they were like, we're going to put cats on the blockchain. And from the video or viral video days, I knew that there was a sort of strange relationship between the internet and cats, in that they really like each other. In fact, at some point we were manipulating when we were doing some like trying to essentially help user posted videos from our site get high up on Reddit. And one of the best ways was like you have a lot of karma and do things. And the way we would grow karma accounts was by posting cat pictures. It was like a surefire way of building karma. Just post cat pictures day in, day out. You'll get a lot of karma. That was maybe like a dubious merit, but I was like, this is really cool. And what I liked about CryptoKitties was that it was the first example of NFTs, but with like additional logic built in. The sort of whole evolutionary algorithm of how you breed the cats and stuff. It wasn't quite a game, but it sort of exposed new things that we could do with NFTs and smart contracts that people hadn't really explored before. And so I got quite excited about that. In fact, I'm a bit bummed out we haven't seen more of that after, really. Like that was, I feel like NFT, mechanically, NFTs have become less interesting over time since then. But yeah, so I was involved in that. I also worked with Open Zeppelin for a little while, which is like an Argentinian security audit slash standard Ethereum smart contracts thing. And other things. I had time to do a lot of different things because I wasn't really like full time on any one thing. But then the next big sort of change was that I started a company called Equilibrium. This was in 2018. And the vision we had there was that back then, most of the engineering expertise around how do you actually build like L1 blockchains was in a very small set of companies. It was basically just like a couple foundations that had that kind of expertise. And we thought that it was very likely that there would be a large number of different kinds of L1s that would try to innovate in different ways, and there would need some of that expertise. And so we basically just set out to build like the best low-level engineering team for blockchain specific things. And we, I think, succeeded in that relatively well. So it grew from 2018. It grew from, well, me and my partner to now it's like around 100 people in total, and also does investing and kind of its own ventures. And Gevulot, which I'm now the founder of, is something we spun out from Equilibrium. So yeah, I mean that's kind of the story. At Equilibrium, I got to work with most of the really good teams in the blockchain space. We worked very closely with Protocol Labs on a Rust implementation of IPFS in the early days. We worked with Ethereum Foundation on Rust implementation of the EVM. We've worked with Starknet and Alio since very early on. Alio, which I gather is actually now sort of live as of some days ago, maybe. Which is pretty exciting. So we worked with them at Equilibrium since the seed round, and built a significant portion of that whole thing. And then more recently, we've also worked with ZK Sync and Celestia and Avail, and the sort of latest generation of top teams. And now in Gevulot, hoping to continue working with a lot of those top teams, but now as a compute provider as opposed to building their systems or helping them build their systems. Was that adequate length?
I think I like how the common theme for all of the ventures was that you put yourself in the middle of the interactions that happen and sort of form connections from those interactions. So from the exchange to the development firm, I think that all sparks that's like where you see the biggest need in it, and because you're involved within that center point, then you can easily see, okay, well, people come in with feedback for this, and you're coming in, and you can see where the market opportunities for that are. So very, very cool process for this.
Yeah. I mean, it's like it's a really fun position to be in, to be kind of pretty close to all the people building the most interesting things, but not like but remain sort of a semi-free agent. So you learn so much from all these different attempts at doing different things, both in terms of like how they go about building their technology, but also in terms of like how do they go about running their companies, how do they set up their foundations, what myriad of things goes wrong or go wrong. And so it's really interesting, and I think yeah, it like kind of emboldened me to be like, wow, you know, uh, I'll do this, and this better than everyone else. These other things I'll try to get better at, and we'll see how that ends up. But it is really fascinating, and I think there's like having been in crypto for so long, I think it's such a shame that still so much of the outward perception is kind of dictated by various negative events and negative bad actors and so on. But when you actually like work with engineers, like I think there's 100% like the most interesting problems in both like financial design as well as in computer science can be found in either crypto or maybe or AI. Um, and so it's just really fun to get to think through a lot of those, and also see different kinds of organizations because crypto has grown to be so big now. Like back in the day, I knew like every project by name. Like there weren't that many. I have a mug, which I at some point was giving as a gift to people as kind of like a reminder because the mug had like a huge amount of logos on it. And it was like all the top projects from 2017 and 18, and like 99% of them are gone. And so no one now has any idea what these logos are. But yeah, it's there's like it's just kept on growing more and more and more. And now it's at a point where like, if you're involved in NFTs, you might be like completely insulated from the rest of the market or the industry. And so I always enjoy getting some kind of seat somewhere so I can kind of, even if distantly, look at different parts of the market and try to understand what they're doing and like how they're going about things.
Yeah, definitely.
But
And I hope you still have that. Hope you still have that mug as well. That's a piece of history.
I have
um,
many. I
but
ordered like 30.
oh, you have many. Okay, so
I,
you're all set.
I gifted most of them to people who probably didn't appreciate
Mm,
it as much as they should have, but I do have a couple.
nice. And I did like how you kind of grew while the space grew from like being involved from the very early start and you dabbling in all of these areas, not just sticking to one, going from like the traditional finance to trying to use Bitcoin as a sandbox to your video startup to NFTs, security audits. So very interesting and very cool to see you dabble in all of these different areas. And then now you're at Gevulot. So very, very interesting to see. Um, Wondering if you could talk a bit more about your thoughts of ZK as the end game. This is a very like common discussion that we see a lot today. So, what do you believe is the big picture, long-term goal for ZK, and what specific factors should we be prioritizing for?
Yeah, so there's so much now. It's even just within ZK, it's starting to be hard to talk in any kind of generalize anything because I don't even know all the projects in ZK. Like maybe almost, but not all. So we wrote a blog post some time ago called the ZK Endgame, and that blog post is mainly sort of focused on trying to emphasize the importance of lowering the compute overhead of ZK. And so whenever you're proving some execution, there's some overhead that you get from ZK, and like it varies how much people think it is, but let's say it's something like 10,000 times overhead right now. And so our argument is that we need to make that overhead as small as possible because like there are many points on that scale where you unlock new use cases. And it's maybe easiest to understand via the extreme, which is like, let's just imagine the ZK overhead was zero. It's probably like, it's almost definitely not going to be zero ever. But if it was, you could easily imagine that like every single company, every single product using AWS would require a proof of correctness of the execution from those providers, because there's no like downside, and it removes trust in the hardware operator. So I think that's super important, and it's something that we're not tracking very well right now. So much of the focus has been around how do we lower verification costs on Ethereum, which is extremely important as well to like make the current generation of rollups viable. But like the sort of more global, beyond just blockchain thing, I think, is very much relating to how low we can make that overhead. In terms of what that, so, well, one more thing I'll say on that is like, I think ZK right now is at a point where it makes total sense for blockchain, because blockchains are incredibly inefficient. Like, blockchains have something like the same overhead, but they're because of re-execution. And so it totally makes sense for blockchains to use that. And there are some use cases in the traditional world which also have sort of similar dynamics where ZK might make sense already today. One example I like to use on this is like things where the overhead doesn't matter because it's so important that a large amount of people can trust the results. One example would be an election. Don't think the world is currently set up to do digital elections very well, but like at some point it surely will be. And there, it sort of doesn't matter what the overhead is. Like, if every citizen was independently able to verify that the election results were calculated correctly, that might be justification enough to incur the cost of the overhead. And then you sort of like start getting more and more things that make sense depending on what the overhead is. And so I really try to emphasize that, because it's kind of the bigger picture goal that we don't need to always focus on entirely, but do need to move forward. And it would be great if we had like some very clear way of measuring it. Shout out to Ingon Yama, who has, I think it's called ZK Score, which is kind of an attempt to do this sort of thing, is like score different implementations on how they perform. But yeah, so that's sort of like, I think what we need to do. I think the utopian vision of ZK is just like a digital world of no trust. Sort of like whether or not you have blockchains, if the overhead is low enough, it maybe doesn't even matter. But it like makes so many things possible, which have like always required trust in the past, not required trust anymore. And I think that's like quite interesting and exciting, and then blockchains make it unstoppable, and that's also interesting and exciting. Like you know, if you're from a country where everything is fine, maybe it's harder to appreciate. But I think, at least for me as a child, even though I didn't really have this situation, the internet was very much like a place to escape to, where I could do all kinds of things and no one would really know, or mainly at that point my parents didn't know. And I think that same principle or that same feeling is something that I would want sort of kind of everyone to have access to. And right now, at least, blockchains seem to be really the only way to deliver that globally. So yeah, that's the high level, I guess, of how I think about it.
Yeah, thanks, Teemu. I really liked the last point you mentioned about your kind of overall vision for the space, making it something accessible for everyone. I think that's something that all projects should focus on. And yeah, very great to see that we're moving away from our current status quo of like in terms of say proving some computation or like having someone do that computation for you, going from trust or just doing it yourself to something where we can provide like a proof of correctness from every provider. So I think that's going to be also very, very big in the future as well.
Yeah.
I'm wondering, yeah.
Maybe so. Just to add to that, like, Gevulot, we're building something we call ZK Cloud, which is really like there's all kinds of practical use cases in the here and now, but really in the long term, it's an attempt to do a decentralized cloud. Blockchains that need to re-execute everything can never reach the kind of performance required to like genuinely compete with Amazon Web Services or Google Cloud. But with ZK, you can have a single node do the computations just like in AWS. And it really just comes down to the overhead. And I think that's like, it's sort of in the same lineage of thinking as like Arweave and Filecoin, and then going back even further, there's stuff like Saya, and a lot of these kind of file storage protocols have thought about this. They've like approached this sort of distributed web, or tried to build towards that, where like even Ethereum's original kind of world computer thing. And I think one issue we've always had is that we haven't had a solution to this specific problem. And now we do. It's not yet as efficient as it like needs to become, but it does work, and there are already use cases. So I think that's really interesting. Like to have, if you genuinely want to get like a global permissionless, censorship resistant internet, you probably need to do it in this way. At least for us, like we're trying to deal with compute. People have largely already solved the file storage problem, but these are like little pieces that over time add up. And hopefully one day there's just kind of like, I would love it if it was just like the end result was just like the internet, and the user just like, has whatever their private key on their machine, and then they connect to the internet, and everything is abstracted away. But everything is also censorship resistant, permissionless, and so on. So I think that's quite an exciting thing. And we, every now and then in crypto, we kind of lose it a little bit. There's like, we get Arweave and Filecoin, and then people are like, like everything goes in cycles. Every idea, nothing is new. It's just like you try the same idea is tried every 3 or 4 years. And then at some point it's time. And I think with regards to kind of decentralized compute networks, now is the time. We have the technology, and it's working in production in many cases.
Yeah, I actually I want to add on to that point of the abstraction. I think like before you weren't able to make credit card payments when the internet came through because it was insecure. Everything was HTTP, and you sort of can just access read web data, maybe write to it. But as soon as HTTPS came through, that enabled so much more businesses to come in and generate value. And now I think a majority of purchases are done through online stores. And so that enabled essentially more of a global decentralized economy rather than it being isolated to a specific location. So I think that the next stage of this is in the Web3 space. And as you said, things being abstracted away so that users don't need to know this information. They can just use it, and it's secured by these systems.
Yeah, I think that I think that's exactly right. And one thing that brought to mind is that I think how would I put it? I think digital, or like sort of computer science, I don't know what the right term to use here is, but like digital technologies broadly are kind of inherently a little bit centralizing. Like people have obviously made this point regarding social media and things like that, where you have network effects. But I think just in general, like back in the day when you just needed to physically go to places and like, you had to have cash, like everything was much more decentralized. The government was, a building as opposed to like this hybrid physical digital entity. And so there was the whole system worked quite differently. And then when you start to digitalize it, the natural inclination for everyone in sort of this previous paradigm, I guess people call it Web 2, is just like, okay, we'll just put it on a server, and then someone runs and operates that server, and that someone is actually very powerful. Like it's almost like before everything was kind of a supply chain with many actors, and now it's the most efficient way is kind of just like have it all in one place and give it all the control to one party. And I think that's quite scary. And so like there's always this balance, right? Like we got the internet, which was kind of decentralized, but then immediately once we got commercial things, it became aggressively centralized in many ways. And so how do we bring that back? Or maybe not back, but how do we like get there? And I think, as many people have noted before me, one big reason why things ended up going this way is that the internet didn't have native money. They even thought about doing this, I think, in Netscape. They thought about it in PayPal. They thought about it in a lot of these companies that were involved in those days. They like tried to figure this out, but then just didn't do it. And I think it may have reshaped the structures quite a lot, if that was a thing.
Yeah, exactly. And like how you mentioned that the internet itself is not really kind of the problem that we're facing right now. Internet itself was decentralized, but then as we added those more commercial components, those big players in, it became more centralized. And now we're on our way to trying to go back to our roots of decentralization. So good to see things on the grand scope of things. I'm wondering if you can speak a little bit more about some of the use cases that you are personally very excited about. You mentioned that like beyond Web3, you see use cases where the overhead costs don't matter as much, like with elections, but wondering if there's any other sort of use cases that you see happening, that you see a lot of potential in, either in the long term or that you see emerging right now, or maybe some use cases that Gevulot is focused on as well.
Yeah, so on the Web 2 side, I think it's very difficult to speculate on what the world of use cases is. I think maybe broadly speaking, I would like anything where something is like, for example, calculated digitally and settled is probably a pretty, like where a lot of money moves around is probably a pretty good use case. Like stock exchanges, like it would kind of be nice to know that you weren't screwed or something like that. Might be like an analogy, but I don't know, to be honest, what the fields in Web 2 will be, and it really does depend on ZK getting sort of viable for those fields. I think the progress in academia, or kind of like the research community, is like very fast right now, but you can extrapolate out, but it might not be correct. So we mainly focus on kind of the clear blockchain use cases now. I think those in the near term are obviously rollups. I think rollups are getting hate right now. And, the Ethereum community, we tried to do something new. And like, it didn't, like, we have like 2 or 3 ZK rollups live right now, and people are like, oh no, it didn't work, it's all going to shit, which is, I think, a little bit insane. But I think as we kind of like mature those, as more optimizations get into Ethereum core to make them competitive and so on, I think they have a very good chance of becoming the way that pretty much everything is done. And even though the Ethereum community hated it, like Solana kind of announced rollups, which is funny after shitting on them for a long time. So yeah, I think those are going to be important. I think that's just like kind of scaling, but also different execution environments, different developing environments, and some new sort of fundamental features like privacy. Like it gives you the ability to attach a very wide variety of different kinds of things to a blockchain, and I think that's actually very exciting, and we haven't even started to see what that looks like. Then there's kind of the coprocessor side, which I think is also very interesting. In my mind, coprocessors and rollups are the same thing, except coprocessors are stateless. So they essentially scale Ethereum, but for these sort of like ephemeral one-off things. And the different teams we collaborate with on these, like Brevis and Lagrange and whatnot, like they would probably have better ideas. But personally, I think the most interesting stuff is probably around like doing algorithmic calculations off chain. So while I'm not super optimistic that ZK/ML or like proven AI models are going to be a commercial thing in the very near term, I do think that's one of the most exciting areas for kind of maybe the mid to long term. And in the meantime, there's probably a lot that can be done with just good old statistics that would be too expensive to do on Ethereum. So I mean, that's, I think, the main near term stuff. Then like a slightly longer term, what I'm especially currently very excited about is proving L1 blocks, mainly in Ethereum, at least initially. But I think if Ethereum figures it out, a lot of people will do it. So I think proving every Ethereum mainnet block is doable today. It probably takes like 3-4 minutes per block if you throw a lot of GPUs at it. Costs like 1 million a year, something like that. Like it's doable today, and it's mainly a question of motivation. So I think that is an exciting path to go down. Lot of different things there that are cool, like the original philosophy of Ethereum. Everyone can verify the whole chain, makes every Ethereum client essentially the equivalent to a full node. That I think is great. But then on a very practical level, it would allow you to take just the EVM and have like a roll up, like no weird, like it's the EVM, but this one thing is a bit different. Like you just grab an EVM and you have a roll up, which is exactly the same as mainnet. So I think that development direction is super interesting. And I think people I think a lot of other L1s are going to start going that route. If you get proving times down low enough, you can even imagine that maybe you stop re-executing completely and you just have validators verifying proofs. That I think is sort of like, in terms of blockchain ZK, like that's the end game, is proving times are so low, the validators don't re-execute. And that gives you basically like unlimited capacity, right? So like you can get a lot of state transitions into a proof. By aggregating proofs, you can expand that out to sort of in like a sort of fractal manner. And so, we can bring down costs to almost nothing. We can have much more complicated programs, which are still efficient to run, and so on. So much more in the direction of like, world computer again. And I know people dislike the term now, but I'm not sure what Ethereum is if that's not the end game. So that's the way I'm talking about it.
Yeah, exactly. And very interesting also to see that a lot of these projects nowadays are focused on the more kind of specialized aspects in ZK. So now we're looking at reducing like compute costs, which is a focus Gevulot has, lowering proving time, scaling. Some are more focused on the application side, like privacy. So very interesting to see kind of the broad landscape of these specific specializations and then the use cases that can come from it. But just on that topic, I'm wondering if you can talk a bit more about like the different stages in the supply chain for someone who wants to generate proofs. I'm wondering on both like the user and the developer side, what you see as the main challenges right now for each of those stages, and maybe which stages you're focused on addressing.
Yeah. So, I mean, the naive kind of structure is that in a rollup needs proof. Somebody generates proof is verified. In practice, it's not more difficult, but like there are more things that are happening, and the market dictates how things go. So as kind of an initial assumption, I think it's important to know that like you can't really control where proving actually happens. And so in a similar way to, maybe you can draw an analogy to MEV boost and MEV, you kind of have this flow to where like someone is, in the MEV case, willing to pay the most for a block. And that is not like one or two step necessarily. Like it's kind of, there are some bounds on latency, but mostly it's just like a search algorithm for the lowest cost. And so the implication of that is that you have like a rollup. The rollup needs some way of deciding who's responsible for generating or having a proof generated. That party is unlikely to actually generate the proof themselves, because they're basically chosen in some fairly random manner, like random leader election, which means that they would be utilizing like fairly significant hardware a very small fraction of the time. Or if they are running that kind of hardware, they're probably running all kinds of other stuff on that hardware. And so what the sort of model is turning into right now is that you have that party, let's say for simplicity's sake, and it's probably the most reasonable way to do it, is you just make it the sequencer's responsibility to have a proof generated. That sequencer then can either generate the proof themselves, use a centralized service. There are a couple of pretty sort of specific centralized services that you can use. They usually don't offer sort of whatever, but like Zaki by Ingonyama is for stuff using Icicle. Supranational has like an API for doing some kind of specific proof, et cetera. So you can use something like that, or you can use something like Gevulot, which is kind of like a generic decentralized platform for doing proving. And then that party generates the proof for you. You get the proof back, and then there's some mechanism by which that party then submits the proof to L1 or a alternative verification location. Initially, people thought that would be the L2. Now there's starting to be kind of dedicated verification networks, I guess you could call them, that attest to Ethereum mainnet. So basically, instead of having the verification contract on Ethereum actually compute the verification, which then means it's re-executed by all whatever thousands of nodes, you verify somewhere else, which is more efficient because maybe it's like the verifier is hard coded and is not a smart contract, or there's less people re-executing or whatever. And then that external service basically like sends a signed message to Ethereum saying this was verified or this was not verified. And so that's kind of, I think, the lay of the land, broadly speaking. The one thing that, like, at least right now, the way the market structure has emerged is that people are almost exclusively competing on cost. And there's some performance constraint, but you're competing on cost. And that can be very explicit. So there are examples of auctions, like the Snarketplace on Mina was basically just like an auction who gives us the lowest price. Auctions have problems because they're very easy to hijack by just offering proofs for free until nobody participates. But that's sort of like the most extreme and explicit version of it. Then there's sort of a lot of middle grounds, like Aztec structure is that the sequencer sort of takes bids, but then ultimately uses discretion to decide. But, you know, the sequencer as a rational actor, at least, you know, at some point, they're just going to choose the cheapest one if that gets it done in time and is reliable. And so there are other factors that people may take into consideration, but within those constraints, it'll always go based on cost. And this is something that we're specifically kind of focused on at Gevulot, because when you have when you're competing almost exclusively, if you're competing exclusively on performance, it's very difficult for anything decentralized to compete. You can get very close when you're dealing with zero knowledge proofs because you can avoid a lot of the problems, but it's sort of like much more difficult. If you're competing on cost, if you're not re-executing, I would actually argue that decentralized systems are more competitive than centralized, or at least can be. And the reason is that a decentralized system of sort of global incentives basically functions as like a global search algorithm for the cheapest compute, the cheapest bandwidth, the cheapest electricity, etc. And so you can look at Bitcoin mining, like, could any one company have orchestrated what is Bitcoin mining now? I would argue no. Like, it's so many localized pockets of information that are being used to optimize kind of very local variables that then add up to the cheapest kind of like underlying cost structure for the hardware. In Bitcoin, those sort of optimizations don't get passed on to the user in any way, shape, or form. But you can imagine in a system as structured a bit differently, like Gevulot, where you are explicitly paying people to do a job for you, where you want the end result, and it's not just random hashing. You can actually get those benefits, and so I think you can compete very effectively as a decentralized network against centralized organizations in this type of thing.
Like one additional
Yeah, thanks,
point
Teemu.
for like centralized and decentralized system is liveness. I think like throughout the development of Ethereum, I don't think there was any downtime for for Ethereum as a whole, at least not that I'm aware of. So I think that that also provides that value, that knowing that your service will continue to run in terms of this open marketplace for people to come in and generate proofs. So I think that that also provides a huge value in comparison to centralized systems where you don't know if they would shut down, and then now you're left with the problem of, well, where am I going to generate proofs in a way where liveness guarantees are critical.
Yeah. Yeah. If we had one company do all the proving for all the rollups, I feel like that would slightly undermine the value proposition of blockchains as a whole. And so, yeah, that's exactly right. And so in Gevulot, you essentially have potentially thousands of servers all around the world that are all capable of generating your proof for you. And then, when you run a proving workload, we just select one of them to do it for you in that moment. But it ensures that you can always kind of get proofs done. And there's some other things relating to this. Like, I think people are a bit skeptical maybe of the idea that like these things would be shut down. And so liveness is not necessarily like the main selling point. But it is like once you need it, you really need it. And so I think it's, if we stray from sort of the original ethos and values of decentralization, we should at least be very aware of when we do that. So I'm perfectly okay with, for example, having completely centralized rollups. I will treat them essentially the same as I would treat a centralized exchange, wherein whatever the government of their jurisdiction could just roll in, shut down the servers, my money's stuck. Right now, as far as I know, 100% of rollups, if the company shut down the servers, I'm not getting any money out. So that's fine as long as we're very, very aware of that. And there are definitely like justifications for doing that in moments, but for what is essentially the roadmap of Ethereum, which is sort of the main decentralized system on which you can build things, we should probably hold kind of the majority of those systems to quite a high standard on their alignment with those values and that ethos, because end users may not realize the difference. There's a lot of very kind of like slimy marketing that goes like, projects rarely tell their users outright that all their money is secured by a multisig if they're in a roll-up. And as far as I know, that is a case 100% of the time right now. So yeah, like, experimental and whatnot, but like we do need to move towards a situation where we have resiliency and having been in this space for, what is it now, like 11, 12 years, I think it's not safe to assume that, governments somewhere would never try to shut it all down. We thought governments would shut it down in about a year in 2012, and I was shocked that didn't happen. And I do think there's enough escape velocity where that's very unlikely to happen sort of very generally. But at the same time, there's all kinds of interests which may want to shut any specific service within the sector down. and if those services are essentially like the promise of Ethereum's future, then that's not.
Yeah, absolutely. And on the going back to the topic of just decentralized proving as a whole, I'm wondering if I'm very curious to hear your thoughts on the different ways of doing so. So, for example, like a single application having multiple provers versus that application outsourcing their proving to some external proof market. I'm wondering if you could compare like the different ways of doing so, maybe some trade-offs that are involved between them.
So I mean, having multiple provers, do you mean like the like a roll up running multiple provers themselves?
Yeah, sure. Just as an example. Yeah.
Yeah. So the only reason to do that, which is a perfectly valid reason, is to try to avoid bugs in the
Hmm.
prover code, right? So I think Scroll is using like a T prover as like a secondary check. Um, Maybe Tycho is doing that as well. Um, Optimally, you just have multiple prover implementations and you compute like multiple proofs for every block. Problem is people don't like additional redundancy because it costs money. Um, so that's it's slightly different. That it's slightly a different problem or like a different topic than whether you should use proof markets or not, because you can do those same things on with using external providers as well, right? So that's mainly a question of like how much additional, I mean, how many additional checks you want that it has gone correctly, and I think people are like, this stuff is really new, so people are quite scared that there's going to be a critical bug. And, you know, who knows how much money could be lost there. Unfortunately, that's also an argument for the multi-sig bridges, because the multi-sig bridges can basically function to prevent massive loss if that happens. But these are sort of training wheels. In terms of really the options for projects like rollups are there's not a lot of options. You either run the prover or whatever multiple provers all yourself, which I think is largely going to be unacceptable sort of narrative wise and is a significant cost structure, which you could probably lower by using external sources. Option 2 is choose some external sources. So basically like a permissioned mechanism where you like, okay, like I don't know, I don't want to call anyone out. I'm a roll up, so I'll like our team will run one prover, and then this team over here will run another one, and this team over here will run another one, and we'll have 3 provers globally separated, whatever. And then the last option, which I think is the one most of these will end up going with, is you just have it be done permissionlessly. And this, again, the easiest way to do that is just make it the sequencer's problem. The sequencer needs to make sure that a proof gets generated. That obviously requires that you have decentralized sequencing to some extent, which is also not something we immediately have. But that's sort of the most simple structure. So you can just slap on, you know, Cosmos SDK, you know, Comet BFT, consensus, and then make it a sequencer's problem, and there you go. And so I think that's sort of like broadly the options, but mostly they'll tend to go to the last one. And then whether it's a proof market or not, like it kind of doesn't matter. Like we're not a part of that process. We're just competing to deliver the lowest cost option for whoever wants to submit that proof. So in the sequencer example, the sequencer would then could, for example, then just offload it to Gevulot and submit the proof, and so on. So they're sort of slightly unrelated, and this is partly because of the fact that you can't really control where it ends up happening. And so there's no like direct integration needed. And it doesn't really make sense to like build in a specific third party proving option. Like it may make sense to have some integrations, like default integrations that are reliable, where you have like, oh, you can, by the way, you can offload to Gevulot, or you can offload to Marlin, or you can offload to Ingonyama. Like we have this built-in integration. But I don't think you want to have it be like one thing and then you're just like here, because ultimately like they're like you want to give people the option to do proving themselves, and also you want to make sure that if any one service for whatever reason doesn't work, then that doesn't like destroy your whole process.
Okay, got it. Yeah, that makes sense. Wondering now if we could transition more into Gevulot specifics. So you mentioned previously that Gevulot's now building ZK Cloud, but wondering if you could talk a bit more about the relationships between the other components that you're also building, like ZK Boost, Firestarter, and how all of those work together.
Yeah. So maybe like a quick timeline of events. We launched Gevulot DevNet back in March. That's been running since then. Is still running. It's a pretty sort of like naive implementation, but it provides a pretty accurate user experience. But it doesn't scale, for example. So it's hard to take sort of production workloads onto that. But for testing things, it's very good. And you can use it for free. It's there to generate real proofs. We've had like 300 organizations and developers give us feedback since then. We've learned many things. And so we're coming quite close to launching. I don't know when this is coming out, but probably very soon after this comes out, we'll launch something we call Gevulot Firestarter, which is basically a production ready version of the system, which scales. We've really focused on developer experience, so you'll be able to deploy just containers as opposed to OS images, and we'll pack them into OS images in the back end. It has allocation, so and economic structures, so it basically functions like it's an end-to-end implementation of ZK Cloud. Not quite feature complete, not directly ready for mainnet, but quite close. And we'll run that as a permission service where we'll run all the validators. So there's actually a Cosmos chain running and so on. But we need to provide a stable environment for people to start onboarding production workloads and really using it, because there's quite a lot of demand for it, and we can do sort of equivalent performance to basically any other system, and we're 90% cheaper than AWS. So that's like a pretty substantial difference, and we just need to now prove to the community and to all the different projects that it actually does work, it will work reliably, etc. And so that's what Gevulot Firestarter is or will be. We're currently onboarding node operators into that. If someone listening is interested in running a CPU or GPU node for that, you can, ping me on Twitter or something. I think there's probably a sign up form somewhere on our website as well. And so that is going to launch, and it's going to run like that basically until such a time as mainnet is so stable we can transition everyone over. And it'll run with credits. So very cleverly, we're using the blockchain to calculate how much compute they're using and so on, even though it's not like of value, but we basically have free tiers, and then you buy buy credits to actually use the compute beyond that free tier. And And then the next step after that is testnet, which is just the same thing, but we let other people run validators. It'll be a separate instance though, so this Firestarter remains stable. And then it's ZK Cloud mainnet. And the only reason we've named these differently is because we do want to have this be sort of like a stable platform for some amount of time, and it's not quite the same thing as like a testnet or a mainnet. So yeah,
great. And thank you again for like laying out all those components. That was something that I wanted to ask you from the beginning, because you guys
asked
have
about
so
ZK
many different
Boost.
products.
Yeah,
yes.
We
ZK Boost as well. Yeah,
we don't actually have that many different products. It's just we have like different iterations.
different.
And different, like it's kind of like a different social contract with the user for them. And so like we struggle with all this stuff quite a lot, because it's like, how do we name this to make it clear what it is? Like we called the initial thing DevNet, and a lot of people thought DevNet meant I run something locally and that's it. And it was an actual like there are 5 massive servers running compute and have been for 6 months. And you can deploy stuff, like you can interact with it. Like totally, like people did not get it at all. In our minds, it was like, one step before sort of testnet. And so that would have made sense, but no. So maybe we'll get better at this. I am hoping mainnet will be clear, and then afterwards it will be clear, because it's just mainnet.
I got it.
But yeah, you mentioned ZK Boost. So ZK Boost is something we announced relatively recently. There's going to be another announcement of it really soon regarding kind of who's participating in it. I wouldn't call it a product, but basically the idea is to create a generic abstraction for proving. And so maybe an easy way to think about it is just like there's a standardized API via which anyone who wants to generate proofs can interact with all the different options for proving. So that can be centralized providers, that can be decentralized providers, it can be whatever. And this really sort of came from, a couple of things. One was that we are integrated with basically like everything, and we've built a lot of these integrations. And then we talk to the teams and whatever, and we're like, please don't break this integration. And then they have an update and it breaks the integration, because there's all sorts of other teams which are doing it differently, and like, they can't take into consideration potentially like 30 different teams doing things a little bit differently. And so we just want to create a very standardized model for that, to make it easier for the projects themselves, like the roll-ups and the co-processors and whoever is using it, to ensure compatibility. So the idea is that sort of the proving options are responsible for making sure that their things work in this integration, and then the roll-ups ensure compatibility with the API. And that will just make people's life much easier. It's sort of like a common integration target. And hopefully we can sort of make it very popular, and then you don't necessarily need to do that many integrations, because like if we do a good job with the community of defining the API, and that is relatively standardized, then you kind of like integrate with, you kind of like know what's coming and the format in which is coming, and can process that automatically, and you can integrate with just ZK Boost, and then kind of have access to everyone using that API in terms of demand flows. So that's what we're trying to do. I think there's like 30 ZK projects, both on the sort of roll-up and co-processor side, as well as on the hardware proving side, who are involved. But it's still early days, but that's the vision, and we hope like the idea is to do it as an open source project with a consortium model, and try to have it be sort of very neutral and everyone can participate, so that it has the best shot of actually becoming a standard. And then that makes our life easier because we don't need to constantly be maintaining every possible integration and making sure that new updates don't break anything.
Yep, got it. And just wondering more specifically about the provers in Gevulot. I know you guys have implemented custom prover sets, so I'm wondering if you could talk Teemu a little bit about like its role within the global prover set and some implications and applications as well.
Yeah. We haven't implemented custom prover sets yet. We have the design. So, well, to be clear, just to explain it a little bit. So we have the global prover set, which is like when you deploy a prover, it gets that prover program gets sent to every prover node, which has the hardware to run that prover. And that's what we consider the global prover set. So it's sort of the generic set. There are/were, which I can get into in a sec, some use cases where the prover needed, for example, access to kind of like real-time data or something like that, which we couldn't easily facilitate with this model. In our model, these are very much like isolated. We run the prover in a virtual machine. It's not connect, like it doesn't, like you can't connect to the internet or anything like that. Otherwise, we'd just be letting people. Otherwise, we'd be building a DDoS platform, which wouldn't be ideal. And so, custom prover sets were a design we came up with to sort of address this. Initially, this was kind of for Aztec, since our understanding was, or the team told us, that the prover will need access to 3 to 4 terabytes of state. It seems, and that's too much state to send over the network as like inputs or anything like that. It takes too long. That may still be the case, but we just participated in Aztec's proving contest, and there the provers are stateless. So we'll see how that all shakes out. But there might be these types of use cases where you do need that. And so custom prover sets are essentially allow a user to define some external software that the node operator will run alongside the Gevulot node, which then we sort of expose an interface between these that's very limited and sort of isolated. But it allows like you to dictate, let's say that you need to run like a Celestia node or some like big database next to the node, so that you can do proving with data that you have locally, if that's a requirement. So that's the general idea. We haven't implemented it yet. We'll implement it the moment there's something that needs it imminently. But it's not super high on our priority list right now. We're currently, this is sort of going a bit beyond your question, but we're currently mostly focused on all kinds of like basic architecture optimizations, but especially on like how to make a large scale parallelized workloads very efficient. So if you have, for example, like Aztec, they do this, there's this proof tree that needs to be constructed. So there's like the proofs that the users compute locally, the end users, and then there's a huge amount of aggregation proofs. So there's like a proof which aggregates 2 proofs, and then those proofs go and then they get aggregated and so on. It creates this proof tree. And things like that, you want to run potentially on like quite a lot of machines, and there's multiple steps, and you want it to be very, very efficient. And this is like, this requires quite a lot of thinking. in a decentralized environment of how do you make, because we have the inherent kind of disability that there are times when we just need to send something over the network, and then that network latency is, whatever, 200 milliseconds. And if a centralized provider could just have a cable plugged in, and that latency is like nothing, right? In practice, the difference is actually not that big, but our sort of initial execution model was very much focused on like proving that happens on a single machine. And so now we're kind of extending that to think about like, okay, like actually what a user might want to do. And for example, if you run a big workload on RISC-0, you probably want to segment it and do exactly that proof tree structure. So what you might want to do is have like let's say 100 tasks that are split between, let's say, 10 machines. And some of those need to be done in sequence, and you want them to be done on the same machine. And then only once you really, really have to, do you like send them to another machine to be aggregated, and so on. So we've been working on this thing that we kind of introduced a long time ago, but have really started focusing on now, called workflows, which is, I like to think of them as execution maps. So it's sort of like the instructions for how your 100 tasks will like be executed in the network. It's kind of like an execution graph or something. So you might have like these two tasks are all executed on these nodes, and then they go here, and so on. And this gives the user the ability to make it kind of as efficient as humanly possible. And we've removed every unnecessary thing from in between. Like we don't do intermediate verifications in the way that we would in the old model. We only have sort of like a final verification. I mean, we do intermediate verifications in the way that RISC-0 and Aztec do them, where like the next node will verify the previous step, but then the final proof is verified by 10 or so random prover nodes. So we don't do that for every step, and so on. I don't know. This maybe went way too far into details, but that's been our focus recently, just because there's a lot of very interesting, very large workloads that we'd like to be able to run very efficiently.
Yeah, that's awesome. No, it's good that you went into that explanation. A lot of thought goes into designing these systems, so you have to always think of how are people going to use them, and essentially develop very concrete solutions for those specific the use cases. And I like how you said that the custom prover sets aren't the focus, because there's more pressing matters that more projects are using as a result. So I like that mindset of very, very pragmatic.
Yeah, I mean, we're a pretty small team. We can only do so much. We need to try to do the thing with the highest impact at any one time. And so, yeah, we try to prioritize very aggressively, and we try to do it based on essentially very immediate user needs. And that, I mean, that's one thing that I really enjoy about this, is that we do have a very well-defined like user customer. Like we need to make it appealing to like this very explicit group of people. Like they need to trust it enough. They need to be able to do their workload on it. They need to, all these things, and like we can just ask them. It's like a finite amount, right? It's not like Facebook tries to figure out what their users want. Like that's slightly different, We just go talk to them. We're like, okay, like what can we do? And so that's really nice. It creates a good feedback loop.
Yeah, exactly. And also really liked how you kind of went into the process of thinking where you can balance your priorities, the design considerations that you want to acknowledge as well. So very, so no worries about, you said the long explanation. I think that was very helpful to see kind of your thinking behind the design considerations that you chose. So thank you for that, Teemu. I'm wondering, just as a last question before we close today's session, for anyone interested in the audience, how can they get further involved with Gevulot?
Well, there's right now, there's a couple things that people can do. The main thing is running hardware for the network. So we're onboarding people to that, or node operators to that. You can obviously go play around with DevNet. You can try to deploy a prover. There's some examples that you can deploy that can be found in our docs. That's just docs.gevulot.com. When Firestarter comes out, you can apply for a free tier if you want to play around with that. That will have a lot more compute, on the order of hundreds of GPUs and CPU nodes. I think that's kind of like the main ones. Of course, if there's going to be all kinds of ways to participate that we haven't announced yet. So for those, I think just follow our Twitter. It's Gevulot at Gevulot_network.
Yeah, got it. Sounds great. And thank you so much, Teemu, for joining us. Really great to hear all of your insights and your vision for the space as a whole, like the architectural optimizations Gevulot is going for, design considerations. All really insightful and lots of takeaways from this. So thank you so much, Teemu, again, for joining us.
Thanks for having me. This was fun. We can do it again at some point.
Yes, would love to.